Yes, as usual, teacher Navasa from Riverflow International, and we are now going to answer also one of the other questions that our learners have submitted. This question was from PLE 2017, and it is in magnetism, one of the topics in P7. I can actually give you also this book, very nice, at only 35,000. Now, the question goes, the diagram below shows a bar magnet with iron firings. So we have a bar magnet, and then iron firings around it. Study and use it to answer the questions that you follow, or questions that follows. Now, I want us first conduct this experiment ourselves and check out here with me. I am going to get the materials from the magnetism section of the science kit made by Riverflow International. So what I'm going to pick there, I'm going to pick some iron firings and I'm going to pour them here on my white surface. Okay, then I'm also going to pick a bar magnet from this section. So this is what I'm going to do. I am going just to do this like this, like this, like this, like this. So this is exactly what they have given us here. This is what they have given us. We have some materials on the North Pole. We also have some iron firings on the South Pole. Now, this is what exactly the teacher needs to perform in the classroom. And do not forget that the science kit will give you everything. Part A, which property of magnets is shown in the diagram? As you can see from my magnet, you realize that this one is one of the properties of magnets, which indicate or which say that the strength of the magnet is concentrated at the what? At the poles. So which property we can say, one another can say that strength of the magnet is strongest or greatest or more at the poles. How do we know that? Because you see, when we came and pushed past the magnet over these iron firings, the particles were not attracted here in the middle, but they were instead attracted at the what? At the poles, which actually show that a lot of magnetism is actually concentrated at the what? At the poles of a bar magnet. That's why we said that. Now, part B says, why were iron firings used instead of sand? I did not carry sand. But actually what would have happened is that sand cannot be attracted. Why? Because it is not a magnetic material. So what happens here? If they were used, why iron firings were used, we say iron firings are magnetic. They are magnetic substances. In other words, they can be attracted by the magnet. You know, iron, silicon, they are one of the metals which are easily attracted by the magnets. And when we go to A-level chemistry, we explain that as we look at the arrangement of electrons in the what? In the energy levels. Now, the substances are magnetic substances, while sand is not. So by observation, what happens is that when we put sand there, it will not be attracted by the magnet. Otherwise, if you also have a question that on magnetism that you would want us to look at, please send it on our number. We'll be able. I sign out still as Teacher Navasa Stewart. Thank you.